Today I'm going to show you that how we can take out the factorial of a number using recursion. So here I have created one file with the name of factorial recursion.c, and here I go. I have to first of all include the header file hashtag include studio.h, and then I have to write int main, and after that I'm going to take the input from the user, which is int n, printf enter n, printf enter printf enter n, and then I'm gonna to write scanf. Why am I using over here scanf? For taking the input from the user. Scanf %d ampersand n, and then I have to write. Then what I have to do here, that for doing any kind of recursion we have to create a separate function. So for that, what I need to do, like suppose I am creating in this manner int x equals to fact, I am passing the argument n, the input from the user, and then I have to write int return 0. Now as return 0, now see over here, as am I calling the function, I'm calling the function over here, so I have to create the function here. So I need to do fact, and suppose I'm creating int x, alright, the container where it should be stored, and it is going to return the int value, so int fact. And see what I'm going to do over here, that I know the factorial, like I'm going to simply write return n into n minus n into fact n minus 1, not n, because here it is stored in x, so x minus 1, and here it will also be x. Okay, so here I have created a container called x, return x into fact x minus 1, and then we are going to print it over here, printf %d comma x. Now let's run the program once and check it, then I'm going to explain you. Enter n, I entered over here 3. What is the issue over here? Let us check. See, I have written int main, int n, scanf, int x equals to fact n. I have created the function over here, int fact by int x. Then I have return x into fact x minus 1. Okay, see, can you analyze and tell what's the problem over here, why the program didn't run? So let me explain you first. I hope these points you would be getting over here. Int n, like int n we created it's a variable type, and we created the container, and it's a integer data type. Then I am taking the input from the user, that's why I'm using ampersand. Ampersand is basically used to tell the address where the container n is. Then I'm using a function which is fact n. I'm calling here over here I'm calling a function, and int x I'm storing it in x, so that for printing it becomes easy for me, and then I'm returning 0. So when I'm calling the function, after this line where the function is called, it goes over here, and if you would have written the function here, then you had to declare the function first, and then you could have used it over here also. There was no issue. Anywhere you can write the function, but it needs to be declared first. And if you are using it here only, then it's certain need of having function prototype, it's not there. So see, int fact int x, so the value of n is passed from here to a container called x, and I have done return x into fact x minus 1. And let me ask you one thing, what is factorials? Like I have to take out the 5 factorial, then it should be 5 into 4 into 3 into 2 into 1, right? In the same manner, if here it is returned x into fact x minus 1, suppose the user entered here is 4, okay? So we also know that 4 into 3 factorial, 4 factorial can be written as 4 into 3 factorial, because ultimately the solution is going to be that it needs to be multiplied to the every number until it reaches 1. 4 into 3 into 2 into 1, right? So in the same manner, here I have to return x into fact x minus 1, right? So what I'm going to do that, and then here, as I took the example of 4, so 4 into 3 factorial. Now the in the x the 3 is stored, right? So 4 into 3 factorial, and after here now 3 factorial is again called. When 3 factorial is again called from over here, again the 3 factorial is called. So 3 into 2 factorial. Now what happens that 2 factorial is again called. So 2 into 1 factorial. And here we have not applied a single condition where the loop should stop. So in this manner, the in recursion you also, like as you are aware that function is called it by itself. So here the function is going to be called by itself at every approach. So here it's very necessary to we need to put a base case. So let me write if x is equals to 1, or it doesn't reach the or x equals to 0, then you what you do, you return 1. Return 1 means you stop the function over here only. Now let us run the code and see it once again. Enter n. I entered 4, 24. Now it is perfectly correct. And we could ask one more thing, that why here we used 0, like x equals to 0. So let me explain you, like if the user entered 2, so 2 into factorial 2 minus 1, 1 factorial. 1 factorial is called, so 1 as the value of x reaches to 1, so 1 into it would be 0 factorial. And I have written that x as the value of x equals to 1 or 0, print it as 1. So here we will get the value of x equals to 1, will directly get that the value of x is equals to 1. And from there, the if like you it's like a tree structure, a graph structure is basically a tree like structure is followed in order to understand the recursion. So as one value you get the value of the 1 factorial, it goes to the it goes again to the from where it was called, and in the same manner it after that it reaches over here and then return 0 is clicked. All right, let's run the code again. Enter n, this time we enter 5, values 20. And you can, if you want that, you could use it in this manner also. Now enter n, this time we enter 8. What's the issue over here? I think some compilation error is again. We should run it and see. Enter n7. There must be some compilation error. Why is it not running? Let's run it once again. Answer it 7 to enter n. If we enter suppose 6, it's a compilation error only, because the code is absolutely right. It's giving the value over here 720, like this. It is giving the value. 3. There's a kind of compilation error because see, when you're running it once again, it is giving the value over here. So here, the how the recursion takes place, recursion is basically the calling of the function by itself, because here the function is itself again called. So this was all for today. I hope you would have got it. Thank you and just keep smiling.